Hello students, this is the fourth part of our module 5 of our course Fundamentals of Artificial Intelligence. So as we know that module 5 is about learning concepts and these are the contents, different types of learning and then introduction to natural language processing. So we know that learning is an act or process or experience of gaining knowledge or skill behavioral modification, especially through experience or conditioning. So, before we begin the next type of learning, imagine teaching a small child how to ride a bicycle. At first, what will happen? The child will fall. When they balance correctly, you will praise them, right? When they fall, they feel pain or discomfort. Over time, what does the child do? The child learns which actions keep them balanced and which actions cause falling. So no one gives the child step-by-step equations or directions, right? Learning happens through trials, feedbacks, and the improvements. So this is exactly the next type of learning which we are going to focus on. This type of learning is known as reinforcement learning. So a machine learns by interacting with the environment and receiving rewards or penalties. So reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. For each good action, what will the agent do? It gives a positive feedback. Whereas for each bad action, the agent gets negative feedback, and that is known as penalty term. Okay, so unlike supervised learning, reinforcement learning does not use label data. The agent must learn entirely from its experience. So, reinforcement learning solves a specific type of problem where decision making is sequential and the goal is long term. In some cases of game playing, robotics, and control system, we can use reinforcement learning. Okay, so if you're considering the artificial intelligence, we have machine learning, right? And machine learning is again classified into three types, that is supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, we have the label data, whereas in the case of unsupervised learning, we will not have any label data. There will not be any label data. So in the case of reinforcement learning, the agent learns automatically using the feedbacks without any label data. Okay, so this is a type of trial and error method. The agent interacts with the environment and explores it by itself. The primary goal of an agent in reinforcement learning is to improve the performance by getting the maximum positive rewards. Okay, so agent explores the environment on its own with the goal of maximizing the cumulative rewards. So learning in reinforcement learning occurs through trial and error method, often referred to as hit and trial learning. Okay, and it is based on the experience and it learns to perform the task in a better way. Okay, so over repeated interaction, the agent gradually discovers which actions lead to better outcomes. For example, a robotic dog learning to move its limbs while initially make random movements, right? But over time, when it learns the coordinated motion through all the positive feedback from the environment, it will try to move in a better way. So, robotic dog learns the movement of his arms is one of the example for reinforcement learning. So, it is a core part of artificial intelligence and all AI agent works on the concept of reinforcement learning. Okay. So the ability to learn without explicit programming makes reinforcement learning a core component of artificial intelligence. Now let's see another example. That is, suppose there is an AI agent present within a maze. Okay, maze environment. The maze is the environment, and his final goal is to find out the diamond. So the agent interacts with the environment, which is the maze, by performing some actions. And based on the actions which the agent is performing, the agent state of the agent gets changed. And it also receives a reward or penalty as feedback. That is, for positive feedback, there will be a reward, and for negative feedback, there will be a penalty. So the agent continues doing these three things, and by doing these actions, he learns and explores the environment. Okay, if the agent moves toward the goal, it may receive the positive feedback, whereas entering dangerous areas results in a negative feedback. Okay, so through repeated exploration, the agent learns which paths are beneficial and which should be avoided. Okay, based on the positive feedback and the negative feedback, the agent will try to correct its path. So this is one of the diagram which represents the reinforcement learning. You can see a robotic agent and a maze as the environment. So the agent will perform some actions upon the environment, and based on the actions, the environment will reward the agent with rewards and change of state. Rewards can be positive or negative feedback. That means rewards or penalties. In this slide, we will discuss about the terms which used in the reinforcement learning. Okay, we have agent, environment, action, state, reward, policy, value, and Q value as the terms which we normally use in reinforcement learning. So agent means that an entity that can perceive, explore the environment and act upon it. Okay, as we saw in the previous slide or previous diagram, robot is an agent. Next is environment, a situation in which an agent is present or surrounded by. In RL, we assume the stochastic environment, which means it is random in nature. In the previous slide, we saw the environment as the maze. Next is action. Actions are the moves taken by an agent within the environment. The actions which are taken by the agent upon the environment. Next is state. State is a situation returned by the environment after each action taken by the agent. So what is the output? Next is the reward. A feedback returned to the agent from the environment to evaluate the action of the agent. That is, it can be a positive feedback or a negative feedback. Next is policy. Policy is a strategy applied by the agent for the next action based on the current state. Okay, and value is the expected long-term return with the discount factor and opposite to the short-term reward. So what is Q value? It is similar to the value, but it takes one additional parameter as current action A. So in short, you can tell like a policy is a strategy used by the agent to decide the next action based on the current state, whereas value represents the expected long-term return from a state considering the future rewards. And Q value represents the expected return for a specific state action pair. So together, these terms or these elements form the foundation of reinforcement learning models. Next, we can see working of reinforcement learning. Okay, to understand the working process of the reinforcement learning, we need to understand two main things, that is agent and environment. Okay, environment, as we saw in the previous slide of the diagram, the environment was a maze and agent AI robot. So each environment can be anything such as room, maze, football ground, or anything. Okay, and agent is an intelligent agent. It can be a AI robot. Okay, so So in order to understand the working of reinforcement learning, we have two main components, that is environment and agent. The agent continuously perform actions and observes the resulting agent. Okay, or the resulting changes. Okay. Now let's see the working of reinforcement learning. Okay. This diagram represents the interaction loop in reinforcement learning. Here you can see 12 states and you can see a diamond and fire. Diamond represents the positive feedback and negative feedback is by fire, and you have a agent, right? So if if the agent reaches the diamond or hits the diamond, he will get a positive feedback or +1. If it is in the fire, he will get -1. So the basic working is that the agent observes the current state, selects an action, receives a reward, transits into a new state, and then updates its knowledge. So this cycle repeats many times until the agent learns an effective strategy in order to maximize his positive rewards. So as we saw in the above image, the agent is at the very first block of the maze. The maze is consisting of an S6 block, which is a wall. S8 is a fire pit and S4 is a diamond block. Okay. The agent cannot cross the S6 block as it is a solid wall. If the agent reaches the S4 block, he will get +1 reward, that is the diamond block. And if it reaches the fire pit, it will get a -1 reward point. So it can take four actions, that is move up, move down, move left, and move right. So the agent can take any path in order to reach the final destination, but he needs to make it in a possible fewer steps or with a little steps. So the agent considers the path S9, S5, S1, S2, and S3. He will get a +1 reward point. The agent will try to remember the next step that it has to take in order to reach the final step. To memorize the step, it assigns one value to each previous step. That is, for each and every correct values, it will give a positive one value. So reinforcement learning is categorized into two, that is active reinforcement learning and passive reinforcement learning. So first we will see what is active reinforcement learning. It combines the concepts from active learning and reinforcement learning to create a framework where an agent can strategically query or explore the environment to maximize the learning efficiency. So it combines the ideas from active learning and reinforcement learning. So in this active reinforcement learning, the agent actively decides what to explore and when to gather the additional informations. So this type of learning is mainly useful in situations where collecting data is really expensive or time consuming. So by suitably selecting some actions, the agent can learn more efficiently. So now we'll see what are the benefits of active reinforcement learning. So first one is improved learning efficiency, then focused exploration, and then reduced cost. So these are the main benefits of active reinforcement learning. It improves learning efficiency by reducing the number of samples required. It focuses on the exploration on the areas where learning gains are highest and reduces the unnecessary data collection. So because of this, the agent can achieve better performance with fewer interactions. Next is the challenges of active reinforcement learning. So mainly designing query strategies, then computational complexity, and then scalability. So even though it has advantages, the active reinforcement learning has disadvantages also. So designing effective querying strategies is really complex. Computation requirements are really high due to the uncertainty estimation, and scaling the approach to large environments can be really difficult. So these factors make implementation more demanding compared to the simpler methods. So next, we'll see what are the mechanisms in active reinforcement learning. So the mechanisms involves active exploration, querying mechanism, trade-off management, uncertainty estimation, and data efficiency. So the agent performs active exploration by selectively choosing actions that provide useful information. It may use querying mechanism in order to request the additional guidance. Okay, so the agent must balance exploration, which gathers new knowledge, without exploitation, which uses existing knowledge to maximize the rewards. So, uncertainty estimation will help to determine where more exploration is needed, and the overall goal is to achieve high performance with the minimal interactions. So, these are some of the mechanisms involved in active reinforcement learning. They are active exploration, there should be a proper querying mechanism, and there should be trade-off management, uncertainty estimation, and finally, data efficiency. That is, active reinforcement learning is mainly designed to enhance learning by minimizing the number of interactions needed with the environment while still achieving the higher performance. Next, we'll see what is passive reinforcement learning. This is a simpler form of reinforcement learning where the agent follows a fixed policy and learns the value of states or state action pairs without actively trying to change or improve the policy during learning. Okay, this approach contrasts with the active reinforcement learning, where the agent seeks to improve its policy through exploration and exploitation. Now let's see the characteristics of passive reinforcement learning. So in passive reinforcement learning, the policy remains predetermined and unchanged. That is, it will have a fixed policy. The goal is to learn the value of states or the expected return for following the policy. Next is no active exploration. That is, the agent does not intentionally explore new actions but passively accumulates the experience while executing the given policy. Next one is learning state values. The primary focus is to estimate the value function, that is V of S, which is the expected cumulative reward stating from state S and following the policy. So the primary objective is to estimate the value function. Okay, and finally, the policy evaluation. The learning process involves evaluating how good the given policy is by estimating the state values or state action values. So as we said, the primary objective is to estimate the value function, right? And this represents the expected cumulative reward starting from a particular state. So, and this process is known as policy evaluation. Next, we'll see what are the benefits of passive reinforcement learning. So we have two main benefits, that is simplicity and policy evaluation focus. So you can tell like the main advantages of passive reinforcement learning are simplicity and ease of implementation. So since the policy does not change, we in the previous slide we discussed that passive reinforcement learning has fixed policy. So the policy does not change. So the learning process is straightforward. It is particularly useful for evaluating the effectiveness of a specific strategy without introducing the complexity of policy optimization. Now we'll see what are the limitations of passive reinforcement learning. First one is no policy improvement. Second one, suboptimal performance. And third one, dependence on initial policy. Okay, the agent cannot discover better strategies because it is restricted to the initial policy. As a result, the performance may remain suboptimal, and also the quality of the learning mainly depends upon the quality of the predefined policy provided at the start. All these limitations are because of the fixed policy which we have in the passive reinforcement learning. Now we will do a comparison between active reinforcement learning and passive reinforcement learning. So active learning, in short, I will summarize the points. That is, active learning gives the agent control over the learning process, allowing it to explore new actions and adjust its strategy in order to maximize the rewards which it will get. Whereas in the case of passive learning, what it follows? It follows a predefined course without actively seeking the new information. So active approach emphasize on the exploration, whereas passive approach or passive reinforcement learning mainly focuses on the observations. Okay. Based on adaptability, that is high active reinforcement learning is highly adaptable, whereas passive reinforcement learning is less adaptable. Why? Because it has the fixed policies. So now when we see the examples of active and passive reinforcement learning, the case of active reinforcement learning, if you're considering education sector, students engaging in hands-on activities and when they ask questions and participate in discussions. So in machine learning, algorithms that select specific data points to label or used to improve a model, such as pool-based active learning. Okay, when a student is engaging in all the activities, that is known as active reinforcement learning. Whereas in passive reinforcement learning, students listen to a lecture or reading a textbook without any interactions. Okay, so in reinforcement learning, in agent executing a set policy and observing the results without attempting to find the better strategies. Thus, we come to the end of Module 5, Part 4. In this video, we mainly discussed on the type of learning, that is reinforcement learning. Reinforcement learning is a type of trial and error method, and this reinforcement learning is classified into two, that is active reinforcement learning and passive reinforcement learning. Thank you.